Students, today we are going to see Module 4. Module 4 consists of three chapters. One is first chapter is Biomass, second chapter is Biogas, and third chapter is Tidal uh, Tidal Waves. So three chapters in Module 4. So first chapter we are going to see biomass energy. In this biomass energy, we are going to see what is biomass production, direct method and indirect method of the biomass production, energy plantation, gasification, low temperature gasification, high temperature gasification, composition and properties of producer gas, temperature of gas, theory of gasification, gasifier and their classification, chemistry or reaction process in gasification, various types of gasifiers like updraft, downdraft, cross draft gasifiers, fluidized bed gasifications, advantages and benefits, use of biomass gasifier, biomass feed characteristics such as energy content, moisture content, dust content, tar content, ash and slagging characteristics, biomass fuel, and then finally application of biomass and cooling and cleaning of gasifiers. These are the things we are going to discuss in this one. So biomass in the sense, normally the plants and trees which receives the solar energy by means of photosynthesis. That means the solar energy is stored in the trees and plants by means of photosynthesis that can be converted into liquid fuel for the suitable of internal combustion engine. So we can use as a fuel. Similarly, we can say that ethanol can also be produced from the cellulose on the large scale. So nowadays the energy cost is very highly increasing. So we have to concentrate on the research of such biological systems which receives the energy from the trees and plants with the help of photosynthesis. So biomass is nothing but it is a energy we are obtained from the plants and trees when it is burnt, because how it is the burning is happening in the sense already the solar energy is stored in the plants and trees, so the heat energy will be obtained when you are burning the materials. So biomass energy content is a storable high energy fuels like ethanol or methane. If you are going for the vegetable crops or vegetables and then other kind of food materials in one particular furnace, and we are waiting for that 3 to 4 days without sunlight, in the sense there is a gas will be forming. That forming of gas is, we call it as a methane gas. So ethanol is produced by using this energy content. The growth of sugarcane and its fermentation, so which will give the ethanol, and the most favorable marginal net energy will obtain from this sugarcane production. So biomass is used for heating, electrical power generations and combined heat and power generations. So several methods are there for the production of this energy. For example, I have shown in this picture is nothing but electricity generation using biomass. So here the storage of biomass, that means various kinds of foods, land manures or cow dungs, everything will be put it in this point, and it is fermented, then it is given to this boiler. In this boiler, due to this the methane gas or ethanol gas, so it will be burned. Okay, then the water which is passed through this boiler is a cold water. Due to this burning effect, the cold water is converted into hot water, and some fluid gas will be added for that conversion of hot water steam into high density steam, hot water into steam. Then the high pressure steam is passed through the turbine. So the turbine starts to rotate and it is connected to the generator. The generator produces the electricity. Again, that high pressure steam which is passing through the turbine, it will come to the district heat network heating network as a low pressure density steam, that is again converted into water, and it will be passed through the passed from the condenser. This is nothing but the biomass electricity production. So biomass is used for heating purpose, electric power generation purpose, and wherever heat and power is required, or sometimes it may be used as a fuel for the transportation purpose. So several methods are used for the conversion of biomass into useful energy. By direct burning method, directly burning the biomass. Synthesis gas production by gasification process. Methane gas production by anaerobic digestions. So these are all the various production schemes. For example, first scheme is nothing but the type of vegetation is suited for the intensive energy plantation and biogeneration selection. That means type of vegetables are suited for the energy plantation and biogeneration. Type and the availability of the land for growing energy crops and plant material production. This is another method of biomass production. Harvesting for conceptual plantation, and techno economic comparison of firing crops directly for the electric power generation with the conversion to clean fuel gas, that is methane or low BTU gas, either at the farm site or at the selected market. These are all the various methods for the biomass production scheme. So biomass production. So sun is the primary source for all kinds of available raw energy sources, including biomass. So sunlight energy is transferred to the biosphere by means of photosynthesis process, which occurs in plant, algae, and some kind of bacteria. So plant matters created by the process of photosynthesis is called as biomass. So plant matter created by the process of photosynthesis is called as biomass. So photosynthesis is nothing but natural radiation. It's a simplest form. The final reaction of this process is nothing but here 6H2O water plus 6CO2, that is carbon dioxide, plus solar energy will give this kind of output. Organic material, it is converted into organic material called as biomass. Okay, so in this process water with the carbon dioxide along with the sunlight, which will be converted into organic material. The biomass refers to those organic matters that are stored in the plants and trees in the form of carbohydrate, as a sugar. Again, it will be transferred to the food chains in the humans, animals, and other living creatures and their waste. Even animal manure also used for the production of gases. Even that other kind of living creatures waste also used for the gas productions or biomass productions. So biomass includes all plant life, trees, agriculture, plants, bush, that wastages, grass, algae, and other residues after processing. So biomass is obtained from forest woods, agricultural lands, arid lands, and even wastelands. So it may be obtained in a planned or unplanned manner. The term is also generally understood to include animal and human waste also we can be used for this one. So biomass has the various advantages like controllability, availability when compared to other renewable options. So there are variety of ways of obtaining energy from biomass that can be classified in two ways. One is nothing but direct method, another one is indirect method. Direct method in the sense the raw material is used to produce the biomass. Energy are available throughout the world in the various methods. Raw materials are used to produce the biomass. For example, forest and wood waste. This is used for the production of biomass by heating or by burning. Agriculture crops and residues. Residential food waste, industrial waste, human and animal waste, energy crops. These are all the raw materials directly used for the biomass production. If you are properly managing this forest, will always have more trees and agricultures. Energy crop management also have crops. We have a residual biological matters are there to taken into the crops. So raw biomass has a low energy density on their physical form and moisture content will be there. So for that we have to go for drying that particular material. After drying it has to be used for the burning in order to produce the heat for cooking. Heat the boiling water in order to produce the electricity. There are twin problems are addressed using of the direct method for cooking or heating. The energy is nothing but that energy whichever we are obtaining, no, that is not sufficient one which is used for cooking and heating. It is not sufficient for heating in the sense it is not sufficient to produce the electricity in conversion of the steam. Cooking also it is not sufficient. Sometimes it may produce excessive pollutions. Some smoke, some noise will be produced. So it is an inefficient way for the direct cooking applications and it is also inconvenient method. It is inefficient method of raw biomass transportations and storage as well as high environmental pollutions are also produced. It is unsuitable for the efficient and effective uses. So we have to go for some of the pre-processing and conversion technology for usefulness of this biomass. Next one is the indirect method. While talking about the indirect method, so previous diagram, previous slide, this is nothing but a direct method. So we are receiving the waste from the conveyor, from the truck, then it is put it in the conveyor. Conveyor will be grinding this the waste material or the crops or hoods, whatever it may be, the trees, the plants. Then it is given to the receiving conveyor. Then it is given to the uh, final storage. So these are all the raw materials. Then in this storage again one more conveyor is used to carry this fuel storage to the, that means raw materials to the boiler, where the boiler this will be heated, that means burnt. While burning what will happen, we are getting the gas or sometimes we may get the ashes. Okay, we are getting the gas and that gas will be passed to the turbine in order to produce the generate electricity, and the remaining thing will be given to the multiple applications. It can be generate ash or it can produce some kind of gas or it can produce the steam for the electricity generation. So indirect method. So biomass can also be used indirectly by converting the energy into electricity or heat. Convenient usable fuels like a solid, liquid or gaseous forms. The efficient conversion process are, first one is thermoelectrical conversion. Thermoelectrical conversion, biomass conversion. Thermoelectrical conversion means the combustion, direct combustion of biomass material in the boiler produce the steam. It is used either to drive the turbine coupled with the electrical generator in order to produce the electricity, or which will provide the heat for the residential purpose or industrial purpose. So the boiler equipment is very expensive, energy recovery is low. So improved pollution control and combustion engines are an advanced one to the any point of emissions. So thermoelectrical conversion. Thermo means heat, electrical means electricity. So heat is converted into electricity. Next one is a biomass conversion to fuel. So biomass is used as a fuel. So nowadays the economic factors are very important for conservation of this fuel. So for that purpose we are using some fermentation and gasification of biomass for converting into fuel. So where the price of the petroleum is nowadays, it is 100 rupees. It is some of the cities or some of the states it is crashed 100 rupees. We have to go for alternate energy for the vehicle transportation. So we can use that biomass gasification which will provide the economical viable, which will produce the biomass feedstock. Biomass conversion process can be classified into again two process. One is nothing but thermochemical conversion. Another one is a biological conversion. Thermochemical conversion in the sense heat is converted into chemical energy. So that means which includes the process such as a destructive distillation, pyrolysis and gasification. Biological conversion includes the process such as a fermentation process and anaerobic digestions. So pyrolysis, we know that it is nothing but bio oil. By burning the rubber or plastic converted into oil, liquid or solid, or it may be a gas. Anaerobic in the sense produces a natural gas like methane gas when it is decomposed by the bacteria in the absence of oxygen. So gasification produces the synthesis gas with the usable energy content. So by heating the biomass with less oxygen in order to make it as a complete combustion. The advantages is nothing but waste is converted into fuel. It is very good of advantage. And the efficiency of the gasification system is more, but some of the factors are affecting this efficiency. For example, biomass moisture content, combustion air distribution, that is amount of excess of air, operating temperature and pressure, exhaust temperature. These are all the factors which is affecting this efficiency of the direct combustion system.